Assalamualaikum warahmatullahi wabarakatuh to our lecturer Sir Hisham. Okay, today my team will present about the single sideband full carrier. Okay, before we start the presentation, I would like to introduce my team member. Okay, firstly is myself, Muhammad Izwan bin Khairuddin. Next, we have Muhammad Shazili bin Khairuzi, Muhammad Zafran bin Zainuddin, Muhammad Zulhaikal bin Johari, and lastly, we have Muhammad Haziq bin Muhammad Khanif. Okay. So in this presentation, we will go for the introduction, the objective for this assessment, the methodology using MATLAB, and the result using MATLAB, and the enhancement, and also for the conclusion. So for the introduction, in amplitude modulation, the amplitude of carrier wave, whose frequency remains constant, change in response to the modulating signal, whereas in frequency modulation, the frequency of carrier varies with amplitude of the modulating signal in FM. When the modulating signal intensity is high, the carrier frequency fluctuates more. There are two important implications. Because noise has large amplitude change, it affects AM transmission more than FM transmission, resulting in a higher signal to a noise ratio for FM. Sideband are created during the modulation process and can be found directly above and below the carrier frequency in the frequency spectrum. In amplitude modulation, we will see a few types of side frequency or sideband, such as double sideband full carrier, double sideband suppressed carrier, single sideband, and also the vestigial sideband. For our assignment, we will focus on single sideband. We will study the bandwidth, power, noise, immunity, fading, demodulation difficulties, phase matching, and tuning difficulties. Okay, that's for the introduction. Next, I will pass to Zul for the objective.
Okay, for the objective, we have a few tasks to complete in accordance to the direction we got. The assignment objective are followed as follows. Develop an analog or digital modulation strategy using any current computer tools as MATLAB, Multisim, or Proteus. Learn how to use MATLAB simulation to determine the wave signal input or output.
For methodology, this is our circuit diagram for single sideband full carrier and the solver. For signal generator, we use amplitude 1, frequency is 10 Hz. For power spectrum design, length of buffer we use 512, number of point of FFT 512, plot after how many points 112, sample time 0.001. For SSB AM modulated passband, with the carrier frequency we use 150, and analog filter design we use, for filter order we use 10, lower passband edge we put the number is 155, multiply with 2 and multiply with pi. Upper passband edge frequency we use 165, multiply with 2 and multiply with pi. So this is the result that we got from the simulink. This is the message signal and carrier signal. Today we got the amplitude modulation for single sideband full carrier. After this, Zafran will explain the simulation.
Okay, I will show the simulation using MATLAB. This is our coding to generate the signal. This is for message signal, carrier signal, USB signal, and lastly LSB signal. Okay, we will run the coding. On the right side, we can see this is message signal. The second is carrier signal. And then the third is USB signal, and lastly the LSB signal. We notice that our sideband signal has higher frequency than carrier signal. Move to the Simulink. Firstly, I will show that this is our circuit for single sideband and modulator. Okay, I will explain about enhancement. Performance of single sideband radio over fiber system through modulation index. Turning the modulation index of the Mach-Zehnder modulator improve the transmission performance of a single sideband radio over fiber system. The system performance might be enhanced if the data signal is modified exclusively on optical carriers or sidebands.
Thank you to the all presenter. So for the conclusion, understanding the goal of this lab, which is to utilize and employ contemporary computational methodologies when assessing the parameters for digital communication, utilizing MATLAB, Proteus, Multisim, and others. We may deduce that we effectively accomplish this simulation. When we compare the message and carrier output waveforms, we can see the difference in the output waveform. That's all from us. Thank you.